All right, thanks everybody for joining today. We have a slightly different topic than what we've covered in the past. Some of you, I think, know David. David has been part of the SCinet DevOps team for a number of years. And in his day job, he does a lot with high performance computing and data analytics and all that fun stuff. But today we're going to be talking a little bit about one of the projects that was done at SCinet at SC19, which involves one of the core functions of the DevOps team there in trying to convey the story of a lot of the data that needs to explain what's going on within SCinet for the demonstrations and things like that. And one of these core functions is being able to manage little tiny video displays to tell that story. So David was kind enough to put together a talk about how all that worked out in 2019, and we didn't get a chance to have a read-up of that at SC20 because it was virtual, but hopefully we will be able to tell this story again at SC21 if it's able to be held in person. So I'm going to throw it over to David so that he can go through this talk.
Thanks, Jason, and good afternoon from Atlanta. My name is David Ediger, and I'm a researcher at the Georgia Tech Research Institute. Like Jason was saying, what we're going to be talking about today is it's really two stories coming together in one. One is a hobby that my group has been working on for several years in video distribution, and then also this evolution of the displays environment at SCinet, and some new ideas that we're trying and hopefully we'll continue to experiment with in the future. So the SCinet DevOps team is a really special group of folks. Today we're going to be talking about something that I think is underappreciated, which is some of the infrastructure around the displays on the show floor. But here's a picture of most of us last time we were able to get together at SC19, where a lot of this work came to fruition. That was my first year as the deputy team lead for the DevOps team, and unfortunately, 20 was virtual, but we're looking forward to the future. So the DevOps team does a lot of different things, some of which have been discussed or will be discussed in this particular venue. A lot of the things that I've been working with over the years have been in the areas of network measurement and monitoring. And that plays a lot of roles in the operations of the network. But then we have this other side of it, which is how do you communicate this to the attendees at the show, via mostly on show floor displays and dashboards. So every year is a little bit different depending on the layout of the show, but in general, each DNOC on the show floor, and there may be somewhere between 5 and maybe 7 of those depending on the layout. Each DNOC has a TV on it that is going to serve as a display. And then the NOC itself typically has somewhere between 8 and maybe upwards of 14 displays. You may be familiar, in recent years, we've had a 2x2 display panel called SCinet Analytics. We also have a kiosk that talks about the racks in the NOC. So depending on what we're doing, we could have a number of different displays there, and all of them have to be driven by a video source, which is something that the DevOps team manages. Now, behind most of these displays is a rotating carousel of dashboards that DevOps has put together. Now, this is a tool that predates me by quite a bit. So I can't even tell you the origin story. Perhaps Jason can weigh in on that. But it's a really useful tool in that on our Apache server backend, we just have a JSON set of objects that describe a number of different playlists. And these are very simple, just consist of a URL and a title for each slide. And then as each client connects to the carousel, based on what IP address they come in from, we're able to feed them up a playlist. And everything is taken care of in terms of formatting. You see sort of a cartoon diagram here where the majority of the dashboard sits in an iframe, and we layer on top of that the SCinet logo and then a custom QR code, which will link a user and their phone who's passing by a display to the actual dashboard itself, so they can see the real data that's being put up there on the TV. So try as I might to find a picture of a DNOC TV in all of our historical archives, my own and SCinet's, I was not able to do that. Apparently nobody photographs televisions, but I was able to find a picture of our kiosk, very similar setup, except for this one is running a different web page that links you to the rack information instead of the rotating carousel. But also, as we're going to talk about, also driven by a Mac Mini, and everything else on the show floor kind of takes on the same flavor. This was from SC18, as you can tell. The one thing we do have is lots of screenshots of what these dashboards look like. So I pulled a few from the archives from SC15. These are some classic SCinet dashboards. So you can see in reality, you know, this lower third that we put on there with the logo and title and QR code, and then really any content we want, we can put on top. And most of our dashboards to this point have been designed specifically for a 16:9 form factor. But you know, even if they aren't, the browser will sort of help us out there. So let's peel back a layer of that onion and talk about how this happens under the hood from a hardware perspective. So each of these displays is driven by a Mac Mini. Now, as far as I can see, looking through some of the archives, the Mac Minis appeared somewhere around 2007, which is really right after Apple released them in the first place. So SCinet was an early adopter. You know, and at the time, and for a good bit of the Mac Mini era, you could get one of these machines for $400 or $500. So they represented a really attractive price point, small form factor, for doing what SCinet was wanting to do. And in fact, today we have more than 20 of these. Again, I could not find a picture of the actual minis, but we have a crate, Pelican case just like this that they all sit in. It rolls on wheels. It's a very nice deployment. So these minis go out, one for each TV all over the show floor. And then we manage them remotely using VNC. So they're programmed to boot up, log in automatically, launch Firefox in full screen, drop the mouse cursor, load the carousel, and go. And if we need to do anything to them, you know, we can get on remotely with a VNC client. So this has worked, you know, very well, really for the better part of 15 years. However, in recent years, these systems really started to show their age. So the last time we purchased new hardware was in SC15. This was about the time, so Apple had mostly abandoned the form factor. You could not get updated hardware. They started soldering RAM to the motherboards, which was a big problem. And then the prices really went up. So, you know, instead of looking at $400 a unit, you know, now you're looking at 800 or more. And that was going to be prohibitively expensive to replace the fleet. Other kind of things, you know, software updates, right? So when you get on site to the show floor, somebody would have to go through and boot all of these 20 machines and get them updated. And of course, they only run for a week every year. So you can imagine what the software update looks like. Apple started tying software updates to Apple Cloud IDs, and that wasn't so good. And then really the thing that the nail in the coffin was the nature of our show floor displays. Our actual dashboards changed really significantly about SC17, SC18 timeframe. And where we used to have all of this static imagery that would be rendered on the backside by our tools, RRDs and things of that flavor, many tools that produced those. We started having a lot of animations, a lot of interactive and runtime rendered, client rendered dashboards showing up in our tool sets. And you can see this today in our Inmon tools, SFlow RT, the Cisco wireless dashboards all have this kind of setup in which they're relying on HTML5 canvases and JavaScripts to manipulate objects, and they do much better with more RAM and more importantly a fast graphics processor, which none of these minis have. And so we started to get to a point where our displays were not able to keep up with the content that we were feeding them, and that was a growing concern for how we would move forward. So we started looking at other options. And the options weren't particularly great. So we wanted to pick something modern that kept costs down. We wanted to make it easier to manage every year. And so the usual suspects come up. The Nooks are one option. Various flavors of Pies. Industrial and embedded systems. Things like the Nooks are just as expensive as a Mini, sometimes more so depending on what you put in it. With the Raspberry Pis, you might have some manageability issues. So we really wanted to know that we could reboot them and manipulate them remotely without having to walk across the show floor. So things like that are of concerns when you're operating a large fleet of these. So hold that thought for a moment, and I want to sort of flip the problem a little bit. So we thought about this as computers spread out on the show floor that are driving these displays, but really what we were wanting to do is we're wanting to push the dashboards to the TVs. And so if instead of thinking of it as a computer problem, you think of it as a video distribution problem, I don't really necessarily care if each DNOC has a different slideshow. You typically can't see two of them at the same time, and we don't usually get requests for custom content in particular locations, with a few exceptions. So what if instead of thinking of it, from a computer standpoint, we think of it from a how do I get video out onto the show floor standpoint? Maybe there's some different ways that we could approach this. So if we go purely just from sort of the professional broadcast video standpoint, there is a solution here, and it's called SDI. So we'll just talk about that for a moment. This is a bunch of standards for moving uncompressed digital video around, primarily over coax, but also over fiber. And so, anywhere where you're doing broadcast video, be it a sports arena or a television studio, these are the kinds of technologies that you're going to see. You can push large amounts of uncompressed video through hundreds of feet of coax in a very reliable way, and you can buy a media converter like you see here to switch over to single mode fiber, and you can really go for tens of kilometers at that point. So this is good gear, very reliable, but cost is going to be an issue. So you can see just for this pair of media converters to go over fiber, you're looking at $500 there. And so this stuff can get pretty expensive pretty quickly. And the truth is that we don't necessarily need raw uncompressed HD video at 3 gigabits a second, right? We're just pushing some dashboards. But this is at least some place for us to think about what the realm of the possible is. Now, the way that the SDI typically works is you bring all your data back, all your video sources back to some central video hub. So this is an example. There are many manufacturers of these. Blackmagic tends to sell gear that's at kind of a very accessible price point, but still being high quality video gear. So this is a 40 by 40 router. There are smaller ones, but the idea is, you have 40 inputs and 40 outputs, and any output can display any one of those 40 inputs. So that's sort of the kind of capability that this can bring to bear. But again, you see the price point it is relatively high, and when you start to add all these things up, you can see that just to do video distribution, you could be easily in the tens of thousands of dollars. And then if you're doing true, broadcast video and you want to record some of these video sources, now you're looking at, potentially upwards into six figures. So this is not going to be a viable solution for SCinet for video distribution, but maybe gives us a place to compare against. Now, going back to sort of one of the things we do at GTRI, my team very often is called upon to support other groups at GTRI in the collection of data when we do field exercises. And this tends to look a lot like SCinet in terms of, we design and build a network. We go somewhere, we run it for a week or 2 or 3 weeks, and then we tear it down and go home. The biggest difference between this and SCinet is that these networks tend to be in very austere environments. Now, that picture on the right there, that's a building with air conditioning. That is very unusual. We've operated out of tents. We typically are used to having generators or batteries and solar. So you don't want to bring your really nice gear out to these types of events when you're doing your networking. And the traditional way of handling this is you go and buy sort of rugged Ethernet gear, and you can buy Ethernet switches that are, managed 8-port, 16-port. They can, run when it's hot out, and you can drop them, and they'll charge you thousands of dollars. They'll have proprietary connections that are, dust resistant, waterproof, and all of those things. And you get really a pretty crummy Ethernet switch for your thousands of dollars. Well, my group started asking the question of, how do you do this really, really cheap? And if you can get the price point down far enough, can we just bring cheap off-the-shelf gear? And if it survives the event, great. If not, we'll buy more. And we've had really a lot of success. So we're going to talk about some cheap stuff. And I can tell you that everything I'm going to talk about has performed admirably in some very harsh conditions. So back to our video distribution problem. Typically, what we want to do in our GTRI work is we have a bunch of computer screens that we want to collect all of that the screen information and then bring it all home somewhere. To some sort of mission control, to a recording facility. So it's kind of the opposite of SCinet, where we're trying to push all the screens out. This is bringing all the screens in, but the idea is the same. So we've gone through a number of different products and leading up to what we did at SCinet, and I'll sort of walk you through the progression because some of these are kind of fun, and some of you might want to consider doing some of this at home because it's quite an accessible price point, as you're going to see. So the very first thing we touched were these Cable Matters HDMI extenders, and it says over Cat6. They're really cheap. You need one of each, obviously, and they run about $90. And what we started with was just going point to point. So these are really designed where you have a transmitter on one end, a long cable, and transmitter on the other end, and then you HDMI in one side, HDMI out the other side. I want to be very particular, though, that we did not want just a Cat6 Balun. We wanted something that was going to actually talk Ethernet frames, so we could use an Ethernet switch. So the way these work is they run at 30 frames a second. but they are capturing individual frames and they're transmitting them over the network using motion JPEG. So every frame is its own image, but it gets compressed. And so your 3 to 5 gigabit per second raw uncompressed video becomes about 120 megs, somewhere in that neighborhood. And this is done with UDP broadcast. So the first thing you should think about is, well, how do I scale this up if I don't want to do point-to-point, if I use an Ethernet switch? Well, and I'll show you on the next slide, they're going to tell you have to have one switch for every set of source or every source. We know that you should be able to do that one per VLAN. And so that's sort of how we want to build up this infrastructure. So in fact, if you look in the manual, they give you these two examples. The point-to-point on the left, on the right, they say, okay, you can put this into a network switch and have 3 receivers. They say up to 8. I can't imagine why it would be limited by 8. But the important thing is that they're trying to tell you one transmitter to a network switch. If you put 2 transmitters, they're both broadcasting UDP. It's not going to end well. Turns out, so one of the downsides of cheap gear, it doesn't quite work so easily as that. The point-to-point worked great. When we plugged it into a dumb Netgear switch, 2 receivers, 1 transmitter, worked beautifully. Plugged it into a Cisco switch, no traffic. Didn't work at all, nothing. Eventually figured out by Wiresharking one of these things that it came out of the box with a source MAC address of all zeros. And apparently Cisco and maybe other vendors realize that that's invalid and just drop it. So nmapping this a little bit, we were able to find an embedded web server that allowed you to do 2 things, allowed you to change the IP address. I don't care what the IP address is. I'm only going to have one on my VLAN, and I'm not going to talk to it. But also allowed you to set a MAC address. So we were able to go in and set MAC addresses, resolve that problem. There's another line in the manual that ordinarily you would gloss over, but you should take to heart. It says you should test every receiver with a transmitter before you plug it into a network switch. Excellent idea, and I'll show you why. So I went to the lab to grab a few of these in preparation for this talk to Wireshark them again. So here you see one that I picked, and again, same boxes, same model number, identical looking gear. First one I look at has this predefined IP address. It's sending UDP broadcast 512 bytes. Looks fine, works great. The next one I grabbed, same IP address, but this time it was sending UDP multicast, and the data frames were twice as big. So this is a little disconcerting to me because I can't tell just by looking at them which ones are which. And the receiver may or may not be able to receive both kinds depending on when it was made. But this is what you get for $90. And if you were going to point, and you kept the pairs together, you'd probably never know. So these were not terribly reliable, but they proved the point and they got the job done. So then we moved on to a second generation, much more reliable piece of equipment that you can get on Amazon. And they're labeled as AGP Tech. And this is basically the same box with just newer hardware. Good news is these came with a valid source MAC, so that was awesome. The bad news is that we bought a bunch of them, and many of the transmitters came with the same source MAC. So that was awesome. We discovered that because when we started hooking these things up, they were working great. And then one by one, a video source would turn off. And it was a bit like playing whack-a-mole. We'd plug one in, transmitter in, and another video source would cut out. And even though they were on separate VLANs, separate ports, and we were using a TP-Link switch at the time. Talk about that a little bit later. And turns out the magic to make this go away is to go into the TP-Link console and turn on IGMP snooping. And then suddenly it was okay with all of these having the same source MAC. And I wish I had a screenshot of it, but basically when you looked at the forwarding table in the switch, you just saw one transmitter per port, one VLAN per port, because that's how we set it up, and they all had the same MAC, and it worked great once we figured out that little hack. So here's an excerpt from the manual for AGP Tech. I think this is just funny. First of all, they claim this will work with 120 meters of cable. I bet it doesn't work well. The other thing, they say that you can have a maximum of 253 receivers. I can't for the life of me figure out why that would be the case. But anyway, they at least seem to indicate that you can do what we are in fact doing. So just to sort of put this in picture terms, what we would do is we would take a switch, the switch on the right, put all of our transmitters in there. Each transmitter is assigned to a different VLAN. And then we would trunk that back to a central switch where we would have our receivers. And depending on which VLAN you put the receiver on, you'd get a different video feed. And you know, at 120 to 150 megabits a second, you know, you should be able to put upwards of 6-ish feeds on a gigabit link. In practice, we found it started to get unstable when we got to 5. Again, there's no error control here. There's no retransmit, so these aren't the most robust devices. But if you were to come along and want to add, you know, a 5th feed, we would just bring up another trunk line, tag that over. And what I've in fact built here is I've built in a networking sort of way, from a network engineer's perspective, I built my own video router. So I have a bunch of inputs and I have a bunch of outputs, and I can make the outputs look like any input I want just by changing the VLAN. And that, in fact, that's what we would do. Now, I want to say a little bit about our choice of switch here. We went on a hunt looking for the very cheapest fully managed switch that we could find. And at the time, that was the TP-Link 2600 series. They have a PoE version and a non-PoE version. The non-PoE is fanless, passively cooled, which is neat. We also had to have a requirement of we needed SFP ports, and we really preferred more rather than less because we were going to be trunking these back with single mode fiber. And from a per port cost, this was as cheap as we could find and still have a usable feature set. So again, you know, we could bring thousands of dollars of Cisco gear out in the field, or we could bring a $200 switch, and if it accidentally got beat up by the heat or dust or run over by a truck, not the end of the world. So here's a picture of one of our first rigs out in the field. This guy ran out there in a Rubbermaid container for about 3 weeks, performed flawlessly, and was really one of the test vehicles for thinking through this this design. Now, the problem with what we've done up to this point is that it requires somebody with a knowledge of a switch and switching architecture and comfortable on a console and all of that, you know, to have to run all of these things. And plus, you know, if you needed to power cycle one of those devices, you couldn't really do that. Later on, we figured out that these encoders, or these transmit units, they're 5-volt devices, and we actually did some deployments where we would use a PoE stripper to take the power off the PoE line, power the transmitter with PoE, and pass the Ethernet on to the transmitter itself. So you can power them remotely and power cycle them remotely if you're using PoE in that way. But we wanted something that you know had an IP address we could talk to, that had a management console, something that we could mess around with. So our 3rd generation solution, and the one that we're going to use for SCinet, are these boxes from URayCoder. And this is a big step up, both in terms of price and in terms of capability. So you're looking at about $325 for a transmitter, which is now going to be called an encoder, and a decoder to receive on the other side. This is moving from that motion JPEG, which was 100 plus megabits per second, to an actual H.264 video stream. So you're only looking at 3 sub 4 megabits per second here. And this brings with it a whole host of possibilities. These are on-VIF compatible, which means that you can hook them up to a network video recorder. And so you can have a bunch of these devices talking to one device that's writing all the video feeds to disk for you. Or in the case of something like SCinet, we can do UDP multicast video and do that with relatively low latency and have multiple receivers all receiving the one video feed. Has a full IP stack, which means that I can actually get into it and talk to it through an embedded web server. Because I'm using multicast, I can have them all on one VLAN, and I can have them send to different addresses, and I can pre-program those addresses into the decoder and channel surf if I want. So really, really big step up in possibilities. So this is what the encoder looks like. Best news here is that I can actually set its IP address. It has an admin GUI that has a login, but it's HTTP, and that's going to be a problem in a moment. And of course, as you look at it, it looks to me like this is basically just a form front-end FFmpeg. But the two most useful features of this GUI are you can look at stream statistics, so you can look at how many frames is it processing, both the sending and the receiving side, so you can see if it's even working. And you can remotely reboot it, which we didn't have to do a whole lot, but if something were to happen, you could just come in over the network and click the reboot button. So doing this at SC19, I convinced the team to buy a few of these and give it a shot. So in the upper right-hand corner, you see our video encoder. This is actually a 4-source encoder. So before I showed you just the single source, this is 4-in-1. And then the decoder down the left, that's what gets plugged into the TV. It's not very big. It's a little bit larger than your wallet. So pretty nice form factor. And what we did is we set up 3 minis, and instead of putting them out all over the place, we just had them sitting right on the DevOps table in the NOC. That's the DevOps switch, so they could plug right in. And so we were able to take those 3 video streams and send them to the 5 DNOCs, as well as 6 of the displays on the NOC. So there were 2 displays on the NOC for the help desk that had sort of custom dashboard type requirements. And so we kept those as regular Mac minis, although the plan is to phase that out. But you see what we were able to do, in previous years, we would have had to come up with, upwards, I guess that's 13, plus, there's a kiosk Mac Mini, so let's call it 14 Mac Minis. We are able to do this here on just 6, which is a decent reduction. I think we can do a little bit more in the future. But because we have a range of hardware available to us, we could kind of pick the best ones. We went out and got some RAM upgrades. We looked at specs and made sure we were using the best hardware. And an underappreciated feature of this is that you can just debug it using VLC. So you don't need a TV and a decoder to know if it's working. I can plug my laptop into the measurement displays network and just open VLC, and I can see the same thing that the decoder is seeing. So that's a really nice feature. Wasn't all roses and butterflies to start with. Couple of things. First of all, I was told by a number of folks that this was probably the first time that anyone had done any kind of real serious multicast on the network in some time. So that was a little bit of an unknown, although wasn't too big of a deal. The first thing that happened is that security flagged us because the encoders have a login page which is unprotected, and so they were seeing the default password, on their taps. And of course, these are also sitting on a VLAN for historical reasons. That was like a lot of the infrastructure, it was directly connected to the internet. So there were a lot of concerns about putting this type of cheap gear on a segment of the network that could be attacked rather harshly. There wasn't really a good fix for how to solve the problem of adding security to these boxes. There's no button that turns on HTTPS. And so the first thing the network folks came up with was to put an ACL in place so that the stuff on the display VLAN could only talk to our measurement VMs and servers. And this didn't work for a variety of reasons, but it was a really funny story. We went out to dinner, and they said they were going to put this ACL in place. And when we came back, all the TVs in the show floor, the display was frozen in time, and the time was 90 minutes ago. And as we were walking to the NOC, there's two TVs that are working. And that's odd. Well, they happen to be the two displays that are on the same physical switch as the transmitter. So we learned right there that the ACL was not being applied at the port level, it was being applied upstream somewhere. So those two were just fine. Everything else was totally frozen. And that was because when they put this ACL in place, they inadvertently blocked all the multicast range as well. But even with that addressed, it still didn't work very well. We had other gear on that VLAN that needed to go out to the internet. So luckily, in the years since all of this was put together, we now have a conference firewall. So we made the request to take that VLAN, move it behind the stateful firewall, and limit access to just the administrative networks at SCinet. But that solved the problem of devices needing to go out to the internet. Was still fine. So all in all, we got there, but we were sort of doing this, in the 11th hour leading up to the show opening. So the reviews I've gotten is that this seems like a great way to go. We're going to continue to pursue this strategy for future conferences. Really, what this is going to enable us to do next is to invest in hardware for better video sourcing. So now that we're no longer tied to this very small form factor and a low price point because we have to buy 20 of them, we can now look at something that has more of a workstation class graphics capability. And we already have some machines for doing the wall displays, the tiled walls, that can drive 4 displays in one machine. So we might consider, a single machine that drives really all the video sources for the whole show floor is one possibility. The other possibility that I think is worth exploring is can you in fact use a virtual machine or virtual desktop as a video source? So take the encoder completely out of the picture. So I know this is possible with something like VLC. I don't know if the performance would be very good, but certainly could remove even one more component. But regardless, if we can make this work, we might end up in a situation where all the video sources are living down in a rack somewhere in the basement, and we don't have to worry about tending them or having them walk off or anything like that. So I'd like to extend a thank you, my appreciation to SCinet and the DevOps team, for getting behind this new idea. Thanks to Jason for inviting me here today, and ESNet for supporting this. And I hope that even though that this is a bit outside of the usual topic space, I hope that you found something here that was interesting, and maybe you can take for a ride at some point. Certainly come see us at a future supercomputing.
Well, thanks so much, David, for going through that. It's certainly an interesting use case. And, when we first started DevOps years ago, something that we never thought that we'd have to reimagine. And your timeline is pretty accurate. around 2006 or 7, the first minis showed up. I want to say 2005. And the software that you mentioned was purpose built for this. If I remember correctly, it was either John Dugan or Jeff Booth or some combination of both of them. And it was designed originally to run on the Mini, and it used Opera of all things because that was the only web browser at the time that could support kiosk mode, until we figured out that the newer versions of Firefox allowed you to do that. And the early days were spent trying to figure out how to protect the machines themselves from people doing nefarious things like walking by with Bluetooth keyboards and mice and being able to manipulate them. And I'm sure that that's probably still happens too. So moving to a system like this, I think would be perfect. So I'll open up the floor here for questions if anybody has them. I had jotted a couple down. So what was the going back to your days with GTRI and trying to get some of this stuff out in the field? Do you have any interesting stories of bad things that happened out in the field as you sort of learned some of the lessons from this? Any animal interference or just severe weather that tempered your expectations with how well this stuff functioned?
Yeah. I mean, the worst weather we've encountered was we've seen snow. The worst I can remember was being in Las Vegas, and it was about 106 for 3 days. And we were really concerned that the PoE switches were not going to make it in that kind of heat, and we were doing our best to shade them. They also had fans, so they were sucking dust in, and we were trying to figure out how to keep them from overheating. And they pulled through okay. And I mean, on the few occasions that we've been able to bring out older sort of legacy Cisco gear, Cisco gear is just rock solid in heat, and so so it's been all right. I think the funniest story, the very first time we rolled out fiber in the field, we had a spool shipped ahead of time, and I got a call about an hour from the test site, and somebody thought they were doing us a favor by rolling out the fiber for us, but they didn't know what they were doing, and they'd ripped the pigtail off in the first 5 minutes. So we had to call our fiber contractor and have them send us another spool. But they were trying to help. So
it's not as bad as some of the stuff that the NSRC guys from Oregon have mentioned about deploying fiber in the fields, especially like in Africa and South America. I think my favorite story there was that somebody came in and sniffed several miles of it because they thought it was copper. They could sell the inside of it. So we have a question from Eric. Did you ever look at using NDI for video distribution?
We did. That was part of an initial survey we had done looking at the technology space. And at GTRI, we looked at that pretty extensively. We were excited about the technology, but the cost was way too high, both from a software licensing standpoint and from a hardware standpoint for what we were trying to do. We were really trying to do it on the cheap.
Okay. And we'll put the call out there again if anybody else has any other questions. And I guess I'll throw out another one here. If we are able to try to do this for 21 or beyond, any sort of additional things you want to modify about the base plan here? Or are you going to be approaching it in the same way?
I think for the most part, we're going to be approaching it in the same way. The thing that I want to challenge the other SCineters to think about is, if there's any way that this enables us to change, where we put displays or how we think about displays and the purpose of them, and if it opens up any new avenues, and I really would like to do more with this than just push dashboards around, but I'm leaning on the creativity of my colleagues to see if there's anything else they would like to do.
So I guess the one thing that comes to my mind is there a way that this could be adapted to a wireless solution, or will it always sort of have to be beholden to a wired VLAN? You know, is there anything in the 5G space, or even just protected wireless channels that would be able to do the same thing? And quality may suffer a little bit, but just more about, would it be possible?
Yeah, that's a very good idea. I haven't used them. The company that makes those decoders and encoders, they have a model that has a Wi-Fi antenna on it. They also have a model, I believe, that I believe will take a 4G SIM card. Haven't touched them myself. I don't know if they're a real product or just a rendering on Amazon, but yeah, I think that would be an interesting investigation of what would it take to do a wireless backhaul. Certainly, the data rate should be fine. It's just a matter of the reliability.
Okay. Well, I'd actually encourage you to maybe do a little bit of what if planning and see how much it would cost. Because speaking SCinet internal here, is we're going to have to get our budgets together pretty soon. If that's an interesting experiment to run as an Indus or an NRE, get a budget and see how much it would cost.
Yeah.
All right. Well, looks like we may be out of questions. So thanks again for going through this stuff, and send me the slides if you can, and I'll make sure that this and the video get posted. For those that are still listening, we are on a 1-week pause, and then we're going to pick up again on March 26th. And it's going to be another talk from our friends at South Carolina, Ellie and Jorge. And they are going to be going over their performance evaluation of BBR v2. And it's going to dovetail a little bit with some of the other BBR v2 evaluations we've had from ESNet and others over the past couple of months. So people who are looking at investigating that, certainly come back on the 26th for that. So thanks, everybody. Hope you have a good weekend, and we'll talk to everybody soon.